So before we start, right, you all might need, so for the next part, if you, let's say you are following me, you will need these packages in the preamble. Yeah. So I think you guys have the slide, so I'll just go next. Yeah, so yeah, so the first one is okay, so the dollar sign is inline equation. So let's say you want to write stuff together with like your paragraphs, so you can just use dollar signs. So like delta is just some symbol, and yeah, you realize that the words inside is italicized, and so you realize that yeah, so one thing to note is that the symbol are case sensitive. So capital D and small d means different delta. One is, yeah, so you can play around and you realize it's different delta. So just be careful that, yeah, it's case sensitive. So and if let's say you don't include this dollar sign, there'll be error message in your output, in your log file. So you can't even write this out because this has to be in a math environment. So either inline or display mode. Yeah, so there's one thing to note. So next one is the display mode. Yeah, so we'll be using a begin equation and end equation, just like in the before everything, there's a begin document, end document. So for equation, likewise, there's a begin equation and end equation. So usually it's a good habit to label the equation. So for easy referencing, if let's say you are writing a long report, it's good to label the equation. And a good format to take is like, let's say, because you can label figure, you can label table and stuff. So like usually for equation, I'll include like equation column, then what's the equation? Yeah. So yeah, so like \double D is also a special function defined in physics package. So this basically means D, like yeah, D is a way to write DW. So you will ask like, okay, let's say I don't want like because I knew that backslash and double D, right? But if let's say I just want to, I can just type D. Then yeah, sure, you can type that. But the D will be italicized. So you see like the Q, right? DQ. Like the D, I didn't use backslash double D. So you see like the difference is it doesn't look very nice. It's like it's italicized, it's slanted. So like it's not very nice. So you sure you can do that, but it just doesn't look very nice. That's all. But yeah, there won't be any error message. So okay, so that's all for that. So yeah, you realize that for line 69, you realize yeah, so when you type reference, if you are using overleaf, right, when you key reference, there'll be a list of options for you to choose. So those options are basically all the label that you have like included. Yeah, so it's actually very easy. It makes referencing stuff very easy. So this one will output a number. Yeah. So like now we can refer to one as and when we want. Yeah. Okay. Yeah. So yeah. So next one is in line 74. So there are different ways to write display equation. So one is you explicitly say begin equation, then you'll be in display mode. Secondly, if let's say you want to write so many words, you just backslash square bracket, and if you have a backslash square bracket, that will also be a display mode. But one thing to take note is that for this for this way of writing, there won't be any labeling. So it's just something to take note. So usually I'll recommend this, but if let's say you just want to keep your document as neat as possible, you can use this lah. But to be honest, it doesn't really make much difference. So I'll just go with this. But yeah, so like you don't have label, you don't have number, and yeah. So also before I forget, so the underscore, right, is basically for subscript, and the caret is for superscript. So for subscript, right, because this is in math mode, but you realize the rest, you see in math mode, everything is italicized. But I realized the word rest was not italicized because I explicitly tell the system like I want it to be text mode. So it's like normal words. Yeah. So that's that. That's all for this part. Yeah, so the word won't be italicized. So more examples. Okay, so yeah, it's a lot. This one there's a lot, and it looks very messy. But let me just show the output file. So this is what the output will look like. So it's actually your favorite Gaussian integral. So in this part, I'll just be lazy lah. I'll just use the backslash square bracket method to write the equation. But yeah, so basically, like I said, backslash is for command. So this command will call sigma, and sigma instead of word sigma will be a symbol sigma. Square root is also a command, so you need backslash square root. 2 is a number, so yeah, just write 2. Pi is also a command, it's a symbol pi. Yeah, so these are correspond to left hand side. So equal is here. So you just have to match term by term. This in is not integer, but it's integrate. So you indicate the boundary lower bound to upper bound by backslash and caret. So backslash is negative infinity. So I caret sorry I not back I underscore my curly bracket. Then inside is what I want to be the lower bound. Then I caret backslash infinity is infinity. It's just a short way to write shorter way to write it. Yeah. So this is basically this. There's a pointer. This is basically this integration sign. Yeah. Then line 79 correspond to this whole thing. So I think there's nothing. Mu is also a special symbol. Okay, so in this line you realize that the bracket. Why do I need to include this? So if let's say you don't include, right, you realize that the bracket doesn't fit the fraction properly. So usually fraction, it will be like the thing will look a bit bigger. So normal bracket will not fit nicely. So you need the quantity. Is a way to adjust the size of the bracket such that you'll fit whatever that's inside nicely. Yeah. So that's that. I think that's all. So oh yeah. So yeah. Then next one is just let me see which one. Yeah, I think all is I got right everything here. Oh yeah, so one thing I want to point out is PDV is also a special command defined in physics package. So let's say you got partial derivative. You don't a way to write partial derivative, you can write in fraction form, then you ddy, ddx, but it's very troublesome. So there's a predefined function, just use it. So this 83 correspond to this thing. So like it looks very yeah, so it's a very nice way to write it. Yeah. So physics package got a lot of predefined function for physicists. So yeah, just download it and it will serve you well. Yeah. So the n here, so usually there's an optional parameter. So if you don't define this n, by default you take to be order 1. So it's just first order. But you want n, there'll be partial 2x, partial 2y. So similarly for yeah. Similarly for dv. So dv, you can also include a square bracket here. So let's say now it's dy dx, but you want d2y dx squared. You can just dv square bracket 2 d2y dx squared. So yeah, evaluate is for this right vertical line. So evaluate, then underscore is for this thing to subscript it. Yeah. So one thing to mention is that if you realize some of my subscript I didn't include bracket, but some I include bracket. So usually it's a good habit just to include a bracket. But if let's say sometimes you're very lazy, so the subscript will take the next character and it will subscript. Similarly for caret, the next character will be superscript. But let's say you got like 2 characters, let's say you got Z, Y. The next Y will not be subscript. So if you don't include a bracket, the system will just by default take the next character to be subscript, and that's all. Yeah, so this is just some point to take note. So a good habit is just for wherever you want to superscript or subscript, whatever thing, even if it's just one character, just include a bracket. Yeah. Okay, so that's that. Oh yeah, okay, so I've actually answered that question. Okay, so in equation, usually for physics major and even in lab report, you probably will not have a one-line equation. There will be multiple line derivation. So this for multiple line equation, you use there are different ways to write multiple line equation. So one way is to use a line. Yeah. So in this, you realize that in a line, I have this n equal. So this basically is a way, the n is like a marker to tell the system, okay, a line using the equal sign. So okay, I'll just show the output. So you realize that this is a line, so it's a multiple line. Everything is a line based on the marker equal sign. So n is just whatever you pair out with the n will be used as the marker. So in this case, the equal sign was used as the marker. Yeah, so this will be a famous if let's say you got the classical mechanics, you'll definitely see this equation. So yeah, so you realize one thing is that I have multiple lines, I have 4 lines. Every line was labeled like 2, 3, 4. So sometimes it can be very annoying because these are all equivalent. It's basically referring to it's not equivalent, it's referring to the same equation. It's on Newton's second law. So actually, let's say you just want it to label one equation. So what you can do is, okay, so what I can do is, remember the asterisk sign? You can actually include like asterisk here to unlabel everything. But one problem is that when you unnumbered everything, so it's not just one equation. It's not unnumbered 3 equations and left 1 equation. So all the equations will be unnumbered. So you look, yeah. So one way to fix it. So this one means all the equation 2, 3, 4 just now will be unnumbered. So a way to fix it is to use this counter, like just now how we manually add the subsection into the table of content. So you can manually add a counter to the equation. So this is just a template lah. So this is add to counter, basically add to, let's say you want add counter to equation, it's just in this bracket you include equation. That's why you add to table or figure, you can just change it accordingly. So the number beside 1 is basically how much you want to add. Let's say you want to add 3. So like, let's say the last counter, the last beginning equation and equation ended at equation 10. So this one add like 1 more to equation 10. So the next one will be equation 11. Yeah. So tag the equation is just a function, a command to basically tag this equation. Yeah. So yeah, add to counter. So yeah, so remember just now when I talked about like different ways to write display mode. So they are the so-called correct way and the backslash square bracket way. So you realize that the backslash square bracket way, there's no label. So you can also use this add to counter to actually label the equation. So I'll leave it for you to try yourself. So so at the end, you will see the output as this. If you so line 88 to 94 will print out this output after you click compound. So there's only 1 equation. So yeah, so we ended with equation 2. So next one is equation 3. Yeah. So yeah. So there's the so one more thing is yeah. So you can try this lah. So you can actually manually add to counter to this equation. Then you can try it for yourself and see what happens. Yeah. So next one is matrix. So like matrix is very important. Maybe not so much in lab report, but definitely in QM. Let's say you want to type out your homework, you'll definitely need matrix. So yeah, so it's either you use the begin equation, or you can just use the lazy method, the backslash square bracket. So yeah, so this is the one in box, the one box in red. This one correspond to this one. So I'll just talk to you about the structure. So just now in a line equation, you realize that this n, right? So this n is a marker in matrix also. So this n will form like it's like the space here correspond to the space here. Then this n correspond to the space here. So whatever that's on the left will be on the left. Then in the center will be center, and on the right of the n will be the furthest right. So so similarly, like to start a new line, to start a new column, a new row, we can use double backslash. Yeah. So also one last thing, but the most important thing is you will always need to sandwich this whole thing inside the begin and end matrix. Yeah. So this is very important. If not, yeah. So also one slight thing to take note. Usually doesn't really affect a lot. Just to take note that this backslash is needed here. You can't just use the function command backslash new line. Yeah, the command new line doesn't work here. You only, because it's in equation mode, so you need to backslash, double backslash. Yeah. Yeah. So of course you got the display mode matrix, but you also have the inline matrix. But but most of the time, right, the inline matrix, even for a 2x2 matrix, is not very nice. So like usually you wouldn't want to write inline lah. But I'm just showing you that you can do it. Yeah. So likewise, you can quantity is to scale the bracket such that it fits all the ABCD entries. So begin, you can begin small matrix, begin big matrix, whatever. So this is just to say like how much space to include for the matrix. And yeah, the structure follows. The N is to align and stuff. Yeah. Yeah, hopefully I'm not going too fast.